Rule 1. Basic rule of differentiation. If y equals ax raised to power n, the basic rule of differentiation says the y dx equals, bring the power down, so the n, which is the power, you bring it down, multiply it with the existing coefficient, which is a, and then write the x back, subtract 1 from the power. The basic rule of differentiation says bring the power down, multiply it with the coefficient, write the variable back, subtract 1 from the power. A quick example: if y equals 3x raised to power minus 2, that means the y dx, differentiation of y with respect to x, will be equal to, the index, the power is -2, so we bring -2 down, multiply it with the existing coefficient, which is 3, write the variable back, subtract 1 from the power. So the y dx equals -2 times 3, that's -6, x, -2, -1, minus 2 minus 1, that's -3. So the answer is -6x raised to power -3. You may leave your answer like this, or you may take it one step further. Since the index of x is negative, we know that if x is raised to power -a, it is the same thing as writing 1 over x raised to power a. Applying this, dy dx equals -6 multiply 1 over x raised to power 3, hence the y dx equals -6 over x raised to power 3, and that's the answer. Moving on to the next rule, rule 2. So what is the constant rule about? The rule states if y equals c, c represents constant, so the y dx equals 0. That is, if we differentiate y with respect to x, the answer will be 0. To enable you to understand why the derivative of y with respect to x is 0, look at it like this. The y dx means we're differentiating y with respect to x. So it simply means if I go to the function of y here, I need to look for an x. If I go to the function of y here, there is no x as a variable here, which means derivative of y with respect to x is 0 because x simply does not exist beside the value here. That's one way to look at it. Let's give a quick example. If y equals 5, that means the y dx equals, we are taking derivative of the function y with respect to x. So we need to go and look at the value that we have here. We have only 5. There is no x. X does not exist in the equation. So because x does not exist, it simply means our answer is 0. derivative of y with respect to x in this function is 0 because the function has no x as an independent variable. The second way to look at the constant rule is, we said earlier that if y equals c, let's assume y is a function of x. If we assume that y is a function of x, that means we can rewrite this equation as y equals c, and then we introduce an x because y is a function of x. However, in order to keep the consistency from the original equation, which is y equals c, to keep the consistency, y equals cx raised to power 0. Once we write it like this, we go from this form to this form. These two equations are equal and we have kept the consistency. How is that the case? That's because y equals c. We know that in mathematics, anything raised to power 0 is 1. So x raised to power 0 is 1. 10 raised to power 0 is 1. 5 raised to power 0 is 1. Any value raised to power 0 or any variable raised to power 0 is 1. X raised to power 0 is 1. Then we simplify, that's y equals c times 1 is c. So we can see that we have this consistency. Now, what is the purpose of us showing this? Let's go from this now. Y equals c x raised to power 0. We are trying to show why the constant rule says the derivative of y with respect to x is always 0. Let's go back to the basic rule. We know that the basic rule says the y dx means we bring the index down, we bring the power down, and in this question, the power is 0. Multiply it with the existing coefficient, which is c. Then write the variable back, subtract 1 from the power. So that means the y dx equals 0 multiplied by all of these values will give us 0 because 0 multiplied by anything is 0 or anything multiplied by 0 is 0. Now we can see that it still holds. Next, we are going to be solving 10 practice questions applying the two rules that we have learned so far. So we'll go through them one by one and explain how we apply the two rules we have learned so far. Question 1 says y equals 10x squared. We are looking for the first derivative of this function. So the y dx, that represents the first derivative, or it can be represented with y prime. So either the y dx or y prime equals, the index is 2, the power is 2, so we bring the power down, multiply it with the existing coefficient, write the variable back, subtract 1 from the power. So the y dx or y prime equals 2 multiplied by 10 is 20, x 2 minus 1 is 1. So our answer is the y dx equals 20x because x raised to power 1 is x. That's the solution to the first question. Second question. Y equals minus 7. Yes, you guessed it right. In this question, we'll be applying the constant rule. Because as we can see, if we want to do the y dx, this equation has no x, or if you want to introduce an x, it simply means the x is raised to power 0. Based on our understanding, we know that the derivative of a function that is constant is 0. So differentiation of y with respect to x, but there is no x. So that means the answer is 0. Third question is y equals 5 divided by x squared. Y equals 5 divided by x squared. Later, we will explain the rule that relates with division. However, that rule is best applied to functions that are cumbersome. This function does not require a division rule or the rule we know as a quotient rule. We simply bring the x squared up. What does that mean? It means if you don't want to apply the quotient rule, which we will learn later, you simply rewrite this function in a way that can be differentiated without the need of a quotient rule. It means we find a way to bring this x squared back to the top here. Because we can't differentiate a function with respect to a particular variable that is at the denominator. That will not enable us to apply the rule 1 and rule 2 that we've learned so far. So in order to apply those rules, we need to bring this x squared back to the top. Remember that we said if x is raised to power negative a, that means it is equal to 1 over x raised to power a. We learned how to take x raised to power negative a to 1 over xa. So what we simply do in this situation is we simply do the reverse. So that means y equals 5. Because this x squared is at the denominator, when it comes back up to the numerator side, it becomes x raised to power negative 2. So 5x raised to power minus 2 is the same thing as 5 divided by x squared. What we simply did was we applied this rule here. Now, since the values and the variables are all on a straight line, on one line, there is no fraction. What we mean by there is no fraction is the variable that we are differentiating with respect to is not at the denominator. So if the variable is not at the denominator, we can take the derivative. But if the variable is at the denominator, we can still take the derivative, but we have to apply the quotient rule. So without applying the quotient rule, we brought the variable back up. Hence, we can apply the rule 1 and rule 2 that we've learned so far. So applying rule 1, that means the y dx, or like we said, y prime equals, bring the power down, that's negative 2, multiply with the existing coefficient, which is 5, subtract 1 from the power. So the y dx equals negative 2 multiplied by 5 is negative 10, and x raised to power negative 2, negative 1, minus 2 minus 1 is minus 3. You may leave your answer like this, or we may return it back in the way the function was given to us, or we may rewrite it in the way that the question was given to us. So the y dx equals, applying this rule, so the y dx equals negative 10 divided by x raised to power 3. That's it. Question 4. Y equals 2z. Y equals 2z. dy dx equals, let's go to this function, y, z. This y function is a function of z. It is not a function of x. So since it is a function of z, that is derivative of y with respect to x is going to be 0 because there is no x here. However, the derivative of y with respect to z will not be equal to 0 because now we are differentiating the function y with respect to z. So applying the rule 1, the basic rule that we've learned, the power of z here is 1. As we've explained previously here, we said if x is raised to power 1, then that means it is simply x. So z is the same thing as saying z raised to power 1. So we bring the index down, that's 1, multiply with the existing coefficient, which is 2, write the variable back, which is z, subtract 1 from the power, so 1 minus 1, that means the y dz, derivative of y with respect to z equals 1 multiplied by 2 is 2, z, 1 minus 1 is 0. So that means 2, z raised to power 0 is 1 because anything raised to power 0 in mathematics is 1. So dy dz equals 2. As simple as that. The takeaway here is that first we did two things. We did derivative of y with respect to x, and we did derivative of y with respect to z. So when we take the derivative of the y with respect to x, because the function has no x in it, so the answer is 0. But when we take the derivative of the same function with respect to the variable that it has in it, in this question, which is z, we apply the basic rule that we've learned. The shortcut is that whenever the independent variable, in this situation z, is raised to power 1, the derivative is always the coefficient. So for example, if you have y equals 3x, derivative of y with respect to x is going to be 3 without no further calculation. So whenever the independent variable, you are taking derivative of the function with respect to that independent variable, in this situation, which is x, if the power is 1, the answer is automatically the coefficient. Next question, question 5. 5 says y equals 3 divided by z raised to power 4. 5. Y equals 3 divided by z raised to power 4. First, we can take derivative of this function with respect to x. That will be equal to 0 because this function has no x. So all of these values are treated as a constant. So that's 0. However, since the function y is a function of z, the equation is a function of z, so we take derivative of y with respect to z, that's equal to, now we can see that taking derivative of this y function with respect to z, this z is at the denominator. As we've mentioned before, if the variable we are taking derivative with respect to is at the denominator and we are not using a quotient rule, before we can take the derivative, we have to bring the variable back to the top. So the function has to be rewritten again. So it becomes y equals 3z raised to power negative 4. Now we can take the derivative with respect to z. Derivative of y with respect to z equals, bring the power down, negative 4, multiply with the existing coefficient, 3, write the variable back again, subtract 1 from the power. So the y dx equals negative 4 multiplied by 3 is negative 12. Z, negative 4 minus 1 is negative 5. We can leave the answer like this, or you may rewrite it as the y dx equals negative 12 divided by z raised to power 5. And that's the solution. Next one, question 6. Question 6 says w equals 5z raised to power 3. Six, w equals 5z raised to power 3. In this, we can see that w is a function of z, which means w is the dependent variable, z is the independent variable. So we take dw dz. The first derivative with respect to z, taking derivative of w with respect to z, is equal to, bring the power down, which is 3, multiply with the existing coefficient, which is 5, write the variable back again, subtract 1 from the power. So that means derivative of w with respect to z equals 3 times 5 is 15, z, 3 minus 1, that's 2, and that's the answer. If you try to take the derivative of w with respect to x, of course, the answer is going to be 0 because this function has no x in it. So the answer is 0. So how will you know? Are you taking derivative of w with respect to z, or you are taking derivative of w with respect to x? The question will always specify which one you're taking derivative with respect to. In this situation, this may actually lead us to what we call partial derivatives. The reason why I'm touching on this issue is just to let you understand how we apply the constant rule. So if a function with respect to a particular variable, if that variable is not in the function or is not beside the values you're taking derivative with, that means you assume all of these values here are constant. Even though there is a variable which is z, you still assume that z is a constant. That's the purpose of me showing this. Next question, question 7. 7 is y equals negative 4x raised to power minus 3 divided by x squared. First and foremost, we need to rewrite this function back in a way that brings this x squared to the top. As we've explained in previous solutions, as long as we are not applying the quotient rule, we can't take derivative of a function. We can't take derivative of the function y with respect to x while the x is at the denominator. We have to bring this x back to the top. So bringing the x back to the top, that means y equals negative 4x raised to the power minus 3, and then x, when x squared comes to the top, it becomes negative 2. The 2 takes a negative sign. Now we have two x's. We have to simplify this further. That means y equals negative 4, because these variables are of the same, that is, the base are the same, these variables are the same, we can write them as 1, and then we add the powers, basic rule of indices or indexes. So x, take only one of the x's, write the power and add them to each other. Why? Because the sign in between them is multiplication. If the sign in between them was division, you subtract the powers. But since the sign is multiplication, you add the powers. This can only be applied when you are multiplying two variables and the variables are exactly the same. So y will be equal to negative 4x minus 3 plus minus 2 plus multiplied by negative, that will give you negative. So we have minus 3 minus 2. So y equals negative 4x to the power of negative 5. Now we can take the derivative of this function. Taking the derivative, the y dx or y prime equals, bring the power down, negative 5, multiply it with the existing coefficient, which is negative 4, write the variable back, which is x, subtract 1 from the power, which is minus 1, minus 5 minus 1. Hence, y prime or the y dx equals negative 5 multiplied by negative 4 will give us 20. Negative times negative is positive. 5 times 4 is 20. So we have positive 20. The variable x minus 5 minus 1 does minus 6. Of course, you can leave your answer like this, or you can take it one step further. Y prime equals 20 divided by s raised to the power 6. And that's the answer. Next question, question 8. Y equals square root of x. 8. Y equals square root of x. Based on the rule we've learned so far, we need to rewrite this in terms of what we can apply the rule, which means we need to write it in a form where we can take the power, bring the power down, multiply with an existing coefficient, and write the variable back and subtract 1 from the power. So we need to rewrite this function. To write this function, know that if we have square root of x, that's equal to x raised to power 1 over 2, or is equal to x raised to power 0.5. So square root of x actually means x raised to power 1 over 2. So rewriting the function that we have, that means y equals x raised to power 1 over 2. Now we can take the derivative with respect to x. So dy dx equals, we take this power, which is half, we bring it down, multiply with the existing coefficient. In this situation, of course, we know that the coefficient beside x here is 1, but there is no need to write it since anything multiplied by 1 is that value. So the existing coefficient is 1, so we can ignore it. Write the variable back, subtract 1 from the power. So the y dx equals 1 over 2 x. 1 over 2 minus 1, half minus 1 is minus half. So that's the answer. You can leave the answer like that, or you can take it one step further. So rewriting it, the y dx equals 1 over 2 multiplied by 1 over x raised to power 1 over 2. So the y dx equals 1 multiplied by 1, that's 1, divided by 2 multiplied by x raised to power 1 over 2 is 2x raised to power 1 over 2. And you can even take it one step further. The y dx equals 1 divided by 2 roots x. Like we said earlier, x raised to power 1 over 2 is the same thing as square root of x. We have written the answer back in the way the question was given to us. Of course, when you get here, you can stop, but because the question is given to us in this form, it is more consistent to leave the answer in the way the question was given to you, except if otherwise stated, but you can leave it in this form, there is no problem. Next question, question 9, says y equals 4x cubed all roots. Y equals 4x cubed all roots. Just like the last question, we need to rewrite this function in a way that the rule can be applied. So we get rid of these roots. That means y equals, and we explain that root means 1 over 2. So we write 4x cubed all raised to power 1 over 2. Because the root is affecting both 4 and x cubed, when we remove the root and write it as an index, it has to affect all of the values. So y equals 4 raised to power 1 over 2 multiplied by x raised to power 3, 1 over 2. So each of them take the power. So y equals, of course, 4 raised to power 1 over 2 is 2. 4 raised to power 1 over 2 is the same thing as saying square root of 4. So square root of 4 is 2. Multiplied by x raised to power 3 multiplied by 1 over 2. So you have y equals 2x raised to power 3 over 2. Now we can take the derivative of y with respect to x. So the y dx equals, bring the power down, 3 over 2, multiplied with the existing coefficient, which is 2. Write the variable back, x, subtract 1 from the power. So the y dx equals 3 divided by 2 multiplied by 2. Of course, 2 will cancel 2. We are left with 3 x, 3 over 2 minus 1. So 2 times minus 1, that's minus 2. 3 minus 2, that's 1. So the answer is 1 over 2. 3 over 2 minus 1 is 1 over 2. So that's the solution to the question, or you may rewrite it in the way the question was given. So the y dx equals 3 square root of x. Or you can take it one step further. The y dx equals square root of 9x. So 9x all roots is the same thing as 3 root x. But this is, you may leave your answer like this, and to take it one step further, this is better. So ignore this. The last question, question 10. Question 10, y equals cube root of 64 divided by x raised to power 2 over 3. Y equals 64 divided by x raised to power 2 over 3. All cube roots. First and foremost, we need to rewrite the equation back in a way that we can take the derivative easily. So y equals cube root of 64 divided by cube roots of x raised to power 2 over 3. We separated this and this with the division sign still intact. So y equals cube root of 64. That simply means which number will you multiply, or which number will be multiplied 3 times by itself that will give you 64. So that is it 2 that you multiply 3 times by itself that will give you 64? No, of course. So the answer is 4, because 4 times 4 is 16, and 16 times 4 is 4. So when you multiply 4 by itself 3 times, you will get 64, divided by, we have x raised to power 2 over 3 into 1 over 3. How did we do this? Well, this is the rule. If you have x raised to power m and it is n roots, so we have x raised to power m all n roots, or n root of x raised to power m, that's equal to x raised to power m divided by n. So if you have square root of x, square root actually means there is an hidden 2 here, but the 2 is not usually shown. So there is an hidden 2, but it's not usually shown. But for simplicity, let's show the 2. And the power here of the x is 1, of course, but it's not usually shown. So that means x is 1 over 2. So which means if we have square root of x, or if we have cube root of x, that means x is, the power here is 1, so 1 divided by the root number, which is 3. Or if we have x raised to power 3, but we are taking the fourth root, so we are taking the fourth root of x raised to power 3, that means x is raised to the power 3 divided by the root we are taking, that's 4. So that's how we were able to convert this to this. Now that we have this function in this format, let's simplify it further. So y equals 4 divided by x raised to power 2 over 3 multiplied by all to the power of 1 divided by 3. So that means we have x 2 over 3 multiplied by 1 over 3. So y equals 4 divided by x. 2 times 1 is 2. 3 times 3 is 9. So that means we have y equals 4 over x raised to power 2 over 9. And as we've learned so far, we don't stop here. We take it one step further. That means we have y equals 4. Take this x, bring it back to the top. It becomes x raised to power negative 2 over 9. Now we can take the derivative. So dy dx equals, bring the power down, negative 2 over 9, multiply with the existing coefficient, multiply by 4, write the variable back, subtract 1 from the power. Dy dx equals negative 2 multiplied by 4, that's negative 8 divided by 9, x minus 2 over 9 minus 1, that's equal, 9 times minus 1 is minus 9, minus 2 minus 9, that's minus 11 divided by 9. That's the solution. We may leave it like this, or you may take it one step further. Taking it one step further, dy dx equals negative 8 over 9 multiplied by 1 over x raised to power 11 over 9. So dy dx equals negative 8 over 9 multiplied by 1 over, in root form, that's 9th root of x raised to power 11. So dy dx equals negative 8 over 9, 9th root of x raised to power 11, or you can just leave it as negative 8 over 9 x raised to power 11 over 9. If you stop here, this is okay, and there should be no problem. Hope you found this video helpful. If you have any question, or if we have made any mistake in the calculations, please comment in the section below. Check the video up here for the next rule, and you may refer to the playlist. If you found this video beneficial, please leave it a like and subscribe to the channel. Thank you very much. See you in the next video, and we'll continue with the next rules of differentiation. Thank you very much.